In this video, I'm going to show you how singly linked list add and remove method work. Let's say that we have an empty singly linked list. In this case, head is pointing at null and tail is pointing at null. Then we want to add a node with data 20 to our linked list. The first step is to make a node with data 20 and point its next pointer to null. Then because 20 is the only element that we have in our linked list, then the head and tail of the linked list both are going to point at 20. Now our linked list will look something like this. Then we want to add a node with data 5 to our linked list, and we want to put it at the end of our linked list. In this case, we have to first make a node with data 5 and point its next pointer to null. Then we're going to look at the tail of our linked list. The tail is pointing at node 20. Now, instead of node 20 pointing at null, the next pointer of 20 should point at 5, which is the node that we have just created. And the tail pointer should also move to point at node 5, because now node 5 is at the end of our linked list. And that is the way to insert something to the end of our linked list. Now, let's say that we want to add -2 to position 1 in our linked list. By position 1, I mean that node 20 is currently at position 0 because it's the first element in our linked list. Then the next element is going to be position 1, the next element is going to be position 2, the next element is going to be position 3, and so on. So if we want to add -2 at position 1, we are effectively saying that we are adding -2 after the first element in our linked list. The first element in our linked list is 20, so we want to add -2 after 20, and after that we're gonna have node 5. So our linked list should look like 20, -2, and 5 after this operation. So the first step in our in adding -2 to our linked list, we should make that node with data -2 and point its next pointer to null. Then we should start from the head of our linked list, and we set a counter to count how many nodes we have seen so far. The counter is going to be 0 because we are at the beginning of the linked list, because we're at the head of the linked list. Then we know that the next element that we see is going to be position 1, and that is the position that we want to insert our -2. In this case, we have to put the next pointer of -2 to point at the next of 20, and we should also manipulate the next of 20 to point at -2. If I rearrange the shape a little bit, I'm gonna get something like this. Now 20 is at position 0, -2 is at position 1, and 5 is at position 2. Now let's say that we want to add 32 to the back of our linked list. In order to do that, first we have to create a node with data 32 in it, and we should look at the tail of our linked list because we want to put our node at the end of our linked list. Tail is pointing at 5. Now 5's next pointer, instead of null, should point at 32, and 32's next pointer should point at null. And then because 32 is now at the end of our linked list, tail pointer also should be manipulated, and tail pointer should look at the node that we just created, which is node 32. And that is how we add something to the end of a singular linked list with a tail pointer. If the tail pointer was not there, you had to start from the head of the linked list and go until the next pointer of some node looks at null. Then because it's looking at null, you know that you have reached the end of the linked list. Then you insert the node that you have just created into the end of the linked list. Now let's say that we want to remove the last element from our linked list. The way to do that is to start from the head of the linked list and compare what you're looking at to the tail of the linked list. So is the node 20 at the end of our linked list, is node 20 is the same thing that tail is pointing at? We say that no, it's not the same thing, so we're gonna move on to the next element. We're gonna see -2, and we're gonna ask the same question: is tail pointing at -2? The answer is no, so we're gonna move on to the next element, which is 5. Is 5 the same thing as tail pointing at? No. Then we're going to move on to the next element, which is 32, and 32 is the same thing as what tail is pointing at. In this case, we know that we have reached the end of our linked list. The next step is to change the tail pointer to point at 5, and we're gonna also change the 5's next pointer to point at null. By doing that, we effectively have gotten rid of 32. Now 32 is not accessible and it's out of our linked list. Now our new linked list looks something like this. Now let's say that we want to remove -2 from our linked list. The way to do that is to start from head. The head is pointing at 20. Is node 20 what we wanted to get rid of? We say no, we wanted to get rid of -2. So we have to move on to the next element. The next element is -2. -2 is what we want to get rid of. So in this case, we're gonna say that we have reached our goal. Now we have to check to see if -2 is what tail is pointing at. In other words, if -2 is at the end of our linked list, we have to also do some tail pointer manipulation. If it is not at the end of the linked list, we don't have to do the tail manipulation. Now we check if tail is pointing at -2. In this case, tail is not pointing at -2, so we don't have to be worried about the tail pointer manipulation. Then the next step is to manipulate 20's next pointer to point at node 5, which is the next element that -2 is pointing at. So now 20 is pointing at 5, and we basically have made -2 inaccessible. So if we can't access -2, we have effectively said that -2 is not in our linked list. Now our new linked list should look something like this: 20, and then the next element should be 5. So -2 is not there anymore, is not accessible at all. Now let's say that we want to remove 5. We start from the head of our linked list and we move to the next element, which is going to be 5, and then 5 is what we want to get rid of. Again, we have to check to see if 5 is at the tail of our linked list. So we compare it against what tail is pointing at, and we see that yes, 5 is at the end of our linked list. Then in this case, we have to do a tail pointer manipulation. Now tail should point at the element before 5, which is node 20. So tail is pointing at 20, and then the next of 20 should point at null. In this way, we have gotten rid of node 5, and node 5 is not accessible, and we are done with removing 5 from our linked list. The next thing that we want to remove is removing node 20 from our linked list. Now, because we have only one element in our linked list, then we have to only examine that element in our linked list against our goal. So is the only element that we have in our linked list 20? Then the answer is yes, so that is what we want to remove from our linked list. So in this case, the manipulation of pointers are so simple. The only thing that we do is to manipulate the head pointer to point at null and manipulate the tail pointer to point at null. Thanks for watching. I will see you in the next video that I'm going to talk about doubly linked list and how to add and remove elements from doubly linked list.